Hello, welcome everyone. Today we are doing waves and actually we are continuing the waves because part 1 have already uploaded. And as you can see, we ended our part 1 at time period. We discussed the relationship between the time period and the frequency. Now we'll continue in this chapter, in this part. And before I move forward, I want to announce that I'm running GCSE crash courses. I'm running for all the subjects, as well as I'm running the doubt sessions because exams are quite near. You may be stressing out and you need some help. So even if you think you need help only for few questions for some specific topic, you can just enroll yourself. You can just book a demo, and all you need to do is just email us at exactacademy@gmail.com. It's not only for GCSE, it's for any class from year 1 to year 13 for any subject. As well as if you want to enroll for the new class, if you want to book a demo for the new session from year 1 to year 13 for all subjects, just email us at exactacademy@gmail.com. So let me move on what you're doing, which is waves. You can access these notes, handwritten notes, as well as the worksheets on our website, which is www.exaiacademy.com. So now in this lecture, I'm gonna start it with the wave speed equation, because we have already discussed what's the wavelength, what is the frequency. Now we will be discussing the relationship between the wave speed, wavelength, and the frequency. So let me see this one. So the equation is wave speed is equals to frequency into wavelength. That's it. It's very simple. Just multiply these two together and you will get the wave speed. Wave speed can be calculated with the other formula as well, which is the most common formula that we use for speed. That is distance over time. So wave speed can be calculated as distance traveled by the wave in given interval of time. Both will give you the wave speed. Now, let me move on to the sound waves. Let me talk specifically about the sound waves. So sound waves are basically longitudinal waves. In the last lecture, we have discussed that what longitudinal waves are. Basically, they are the waves in which the particles vibrate in a parallel to the wave propagation. The vibration of particles are parallel because they move to and fro. So the direction of both of them are parallel to each other. So longitudinal waves, how they propagate, that we also discussed, that they propagated by rarefaction and compression, whereas compression is the area where all the particles come closer to each other, start compressing each other and creates a very high pressure zone, whereas in rarefaction is the area where they have moved apart, they are not compressing each other, and it's a low pressure zone. And by compression rarefaction, the waves keeps on moving in a forward direction. This is how the longitudinal waves propagate. Now the sound waves are the longitudinal waves. That means the sound waves also propagates in the similar order. So how can we define sound waves? Now the important thing is the sound waves are the mechanical waves that we discussed in the last lecture as well, that the mechanical waves are the waves that require the medium to travel, and sound waves are also the example of the mechanical waves which needs a medium to travel. And this is the reason sound can never travel in a vacuum, because in vacuum there are no particles, because they are traveling by the vibration of particles, and if in vacuum there is no particle, how will the sound wave travel? Definitely, this suggests that the speed of sound is completely dependent on the medium. While when it travels in air, the speed of the sound is 330 meters per second. Now, you might be thinking that in this case, then the sound must be traveling fastest in air, but this is not the case. Sound travel least in gases, whereas it travels faster, or you can say fastest in solids. See how? Let me see what is the arrangement of the particles of solid, liquid, and gas. Then it would be easier for you all to understand why the sound is faster in solids. You can see the molecular arrangement in three different forms, which is solid, liquid, and gas. Clearly in solid, the particles are all very closer to each other and they are regularly arranged. That means they all have a equal amount of distance between them, and that distance is very small. Whereas for the liquids, you can clearly see they are arranged in a not a very regular pattern. They are quite irregular in the pattern. There is no particular way in which they are stacked over each other, and there is a gap among them as well. So which shows that there is a little bit gap as compared to they are quite away from each other as compared to solid, as well as they have a weaker intermolecular forces. And if we go on to the gas, we get to know that the particles are way away from each other. They have the least intermolecular force. They are just randomly moving here and they are not arranged at all. The distance is very larger. Now let me try to understand how sound travels. When sound travels, when the energy enters, what it does is it energizes the first part molecule. Then the first molecule start to vibrate. This vibration will transfer energy to the next molecule. Now it will gain the energy as well. Then the same thing will happen, and ultimately energy will be transferred from one point to another point. Similarly, it will pass through every particle, every molecule, and sound will travel, or any wave will travel. Now, if the gap between the molecules is quite smaller, then what will happen is that it will take a very less amount of time to move from one point to another point, right? Because the gap is very small. The main aim is that how one molecule is transferring energy to the other molecule. If they are very closer to each other, that means the whole thing will be very quick. If the gap is greater, then it will take more time to transfer the energy. And here that means when this molecule will gain the energy, then ultimately travel a whole lot this one and then energizes the other molecule. So in order to transfer the energy, the time taken would be least in solids. And we know that speed is, if the distance traveled would be say constant, then I would say speed is inversely proportional to time. So if the time is smaller, speed is faster. So if the time taken by the wave to travel in solid is very small, that means the speed is very faster, and this is the reason the sound travels fastest in solids. This is sometimes they ask you in the question, like this question in the exam, and I'm just writing down the answer. This is the answer that you're supposed to write down in exam, that in solids molecules are tightly packed with each other. That means the distance among them is very smaller. So when sound wave travels in solid, it takes very less time for them to travel from one point to another point because the distance is very small. So time taken would be very small, and hence this shows that the time is quite like the speed is quite faster, and this is the reason the sound travels fastest in solids. Now there is a very common question that they ask you in GCSE, which is that how human ears are able to detect the sound waves. So let me understand that. See, this is the anatomy of the ear. The ear is divided into three parts, that is the outer ear till here, then the middle ear, and then the inner ear. So when sound waves travel inside it, it travels through your ear canal and ultimately reaches to your middle ear, and this part is known as eardrum. You can clearly see here it's written as tympanic membrane, but we use the word eardrum basically. So it enters the eardrum by particles keep on vibrating, enters in your ear, and then passes the vibration to the eardrum. That means now the eardrum also starts to vibrate, and this eardrum will send these vibration to the three tiny bones. Names are malleus, stapes, and incus. Important work of them is to amplify to transfer the vibration was the work of your eardrum, and then the eardrum transfers the vibration to these three bones because they actually amplify. That means they are increasing the sound vibration, they are increasing the frequency of the sound waves. So then these vibrations are sent to the cochlea, which is a snail shaped structure, and it's filled with the fluid. So it's completely filled with the fluid. Now what will happen that the hair cells that are near the wide end of the snail shaped cochlea detect the higher pitch sound, whereas those are that is closer to the center more to the center, they detect the lower pitch sound. When this happens, there is a chemical that will be rushed into the cells and it creates a electrical signals. Then the auditory nerves basically carries these electrical signal to the brain, which turns it into the sound and that we can recognize and understand. This is how the human ear detects a sound. And now I'm writing down what you're supposed to write in the exam. So this you're supposed to write, and you can shorten it according to in which marks they are asking. If it's 3 marker, 4 marker, accordingly you can write it. So answer would be that the sound waves enter your outer ear and travel through the ear canal and reaches to the eardrum. On catching the vibration, eardrum starts to vibrate, and this further sends the vibration to 3 tiny bones. Not necessarily you have to write the names of the 3 bones, it's fine, you can skip it, that is located in your middle ear. These bones basically amplify the vibration and send it to the cochlea. It's a snail shaped filled structure filled with fluid. Even you can skip this one, snail shaped filled with fluids, completely fine. You can, if it's just 2 marker, you can skip this whole part as well. A snail shaped cochlea ripple. This you can completely skip. But again, it would be dependent on the number of the number that is allotted to the question. So filled with the fluid, then the vibration caused the fluid inside the cochlea to ripple, and it produces, basically as we discussed, the hairs and everything, but that we are not including in the answer. Directly we can write that this produces electrical signal which then are passed through the auditory nerve to the brain, and where now they are understood as the sound waves. So in this way the ear is able to hear everything. Now let me understand the properties of the sound waves. See, the properties of the sound wave is exactly the property of any longitudinal wave, but the more specifically is the two terms that are important when we study the sound waves. We know the frequency and amplitude, but as soon as we start studying the sound waves, they change their name and we use the word pitch and loudness instead of the frequency and the amplitude. Definitely we use that as well, but in general terms we use the word pitch and the loudness for the sound to describe its quality. So what we can say that the frequency is related to the pitch. So if I'm saying that okay, someone is singing in a higher pitch, that means the frequency is more, that means through his throat he is producing more vibrations in a second. Whereas if I'm saying someone is singing at lower pitch, that means the vibration is lesser and so is the frequency is the lesser. We also describe the quality of a sound according to its loudness. How much the loudness is, volume is greater, volume is lesser, please increase the volume, decrease the volume. So the loudness is related with the amplitude. Now if I'm going to compare these two, this is A and this is B, and if someone asks me like which one has more pitch, which is a higher pitch is definitely B. Why? Because the frequency is more. Frequency, that means how can you know that frequency is more? The wave is repeating itself more number of times in a given interval of time. They are same in a given interval of time. Its frequencies, it has completed only one cycle, whereas it has completed 1, 2, 3 cycles. So we can say it would be 3 times this one in terms of frequency, in terms of completion of waves. So from here I can say that B has the higher frequency. So which one has higher pitch? Obviously B has higher pitch because B has higher frequency. So answer would be B. Similarly, out of C and D, which one has higher volume or loudness? Which one is louder? Simple, we can say which one is louder. So louder is by the amplitude. Amplitude is the maximum displacement. Clearly D has a maximum displacement. This is a smaller, this is a greater. So here I would be saying that D is the correct answer because it has higher amplitude. So in this way we can understand how the sound waves are, and even through the diagram we can understand that which one has a low pitch, high pitch, loudnesses, or lower, higher. So that means frequency and amplitude are very important to describe the sound, and on the basis of frequency the sound waves are categorized as three types: the infrasound, the audible sound, and the ultrasound. So as I described you, the sound waves are divided into three types. Infrasound waves are those sound waves that have the frequency lesser than 20 hertz. We cannot hear it, but it is said that some animals and even the infants can hear the ultrasound waves. These are very low pitched sound waves. Audible sound waves, they got their name because we are able to hear that it's between 20 hertz to 20,000 hertz. But it's not necessary that every human can hear from 20 to 20,000. In between we can hear. The range can be any. And as you age, then you will lose your ability to hear the low pitch sound. So maybe like it is from 20 to 20,000, but not necessarily that you will now be, if you are in your 30s or 40s or 50s, you will be able to hear that low pitch sound. The third one is the ultrasound, which has a frequency more than 20,000 hertz. They are very high pitched sound. The ultrasound waves have a wide range of application in medical and industrial, etc. But the most common question that the GCSE asks is all about the ultrasound imaging. So now let me discuss specifically about what is ultrasound wave and how we can use it in a different fields. Now we have to focus on ultrasound. Let me see its application. The basic definition would be that ultrasound is a type of longitudinal wave which has a frequency above 20,000 hertz. Now there are different species of animals that have a different hearing ranges, and they can hear like the bats, they can produce the ultrasound and can do the echolocation with the help of that. Or we can say that the dolphins use the ultrasound in order to navigate. So they are different animals. Some animals are able to hear infrasound just like the elephants. Some are able to hear the ultrasound. So every animal and the species has a different hearing range. But let me focus on the ultrasound. The uses of ultrasound are in industries and medical. Like in industry, it's used to clean the jewelry. For cutting, ultrasound cutting is also used to cut the metal precisely with the like to the clear dimensions, to the up to the exact dimensions that we are supposed to cut it. Or in the medical, it's used to break the kidney stones, and ultrasound imaging is used. Now in GCSEs, the maximum questions that you will see are around the ultrasound imaging, so we will be focusing more on ultrasound imaging. So let me see what are the uses of ultrasound. So these are some of the applications of ultrasound that I have written. That is to monitor a baby in the womb, monitoring the fetus. So they basically monitor it and will give a due date that when the mother can expect to have a baby. The breast ultrasound to detect the cancer. If there will be a lump, it will be helpful to detect that. To detect a kidney stone, if there is a stone in kidney, the abdominal pain, sometimes you have a severe abdominal pain, and doctors are not able to know it, so they write the ultrasound imaging for it. Cleaning and drilling of the teeth, the dentist use this one. Drilling, cutting, grinding, welding of the materials in industries, and the echo technique, which is sonar. So these are some of the uses of ultrasound, out of which we will be focusing on this one, that is the monitoring and detecting stone. This is basically the medical part of doing ultrasound imaging, that how the imaging is being done, and the echo technique. The questions are mostly on it. So let me see it. This is the whole setup of ultrasound imaging. You can see that this is a sonogram. This is basically, it's a computer CPU inside which the doctor can see what's happening, And this is the patient lying, and the doctor is holding a transducer in his hand, and this transducer is actually sending the ultrasound signal. So when it reaches to body, it actually reaches at a different layer of your body and then gets reflected back from those two. And this reflected rays, what's happening, you can see this transducer is sending in a purple bluish color. You can see it's sending that ultrasound, and after reaching to different organs, obviously this is the property of any wave, to get reflected, to get refracted. So it will undergo both of these phenomena. And when the finally ultrasound gets reflected back, it was again taken by or received by the transducer, and furthermore it's being amplified by different setup. Here you can see that this is a setup of ultrasound imaging, that is a screen, a speaker, the controllers, computer, and the printer is used to take out the printout finally. Whereas this is the transducer, that is the main thing which gives off and takes the reflected sound waves. Now let me solely focus on it, how exactly this transducer works and produces the ultrasound. This is your transducer, or called as transducer probe, but we are using just the word transducer. What happens is, this is the main part of the ultrasound machine, and this is the one that I have described, that it gives off sound waves and receives the echoes, reflected sound waves. The transducer generates these sound waves on the principle of piezoelectric effect. Obviously, piezoelectric effect is not in our syllabus, but I'm just explaining what exactly happens here. They are made up of, if I talk about the material of this, they are made up of piezoelectric crystals. So the property of piezoelectric crystal is that as soon as they take up the electric current, from here the electric current is being supplied, they are connected to an electrical source, a voltage is supplied. So as soon as the electric current is supplied to that piezoelectric crystal, they have the ability to change the shape rapidly. And while doing so, the rapid shape change of the crystal produces a sound wave. It produces the vibration when basically it tries to come back to its original position. Because what happens, when you provided the current to it, it changed the shape. Maybe it gets enlarged or squeezed, it depends. Now this is the nature of every object, that it resists any change. So when it tries to come back to its original position, then it will give off the vibrations, and that is in the form of ultrasound. If you are providing higher current, the energy would be higher, the vibrations would be higher, and the ultrasound wave will be produced. So this is the part where we get to know that how exactly the ultrasound is produced. After the production of ultrasound, doctor places the transducer over the body. When a wave travels from one medium to another medium, it gets refracted. I'm talking about refraction. The refraction will take place. And when it touches any surface, reflection will also take place. So both reflection and refraction will occur. So as soon as the sound waves are being sent, then when it means, because inside our body every material has a different density, the skin has a different density, muscles, bones, organs, so definitely they will get reflected back, as well as they are moving from one medium to another medium, refraction will also occur. Once it reaches to finally which you want to detect, it come back to the transducer takes back those waves, those signals, and then processed with the help of sophisticated instrument, and the doctor will be able to know live what is happening. When we will study reflection and refraction, I'll also explain this part there as well, that how exactly reflection takes place, because you will find so many detailed questions around it. So let me see how, what we are supposed to write when the question is being asked that how the ultrasound works. So basically we can say that ultrasound imaging uses the ultrasound wave to view inside the body. And this is all you have to write in your main exam. If the question is how does the ultrasound imaging work, we need not to describe about the piezoelectric crystals and about the effect. Only we have to write that the machine uses a transducer, and it produces the ultrasound when electric current is supplied, or you can say with the help of voltage it produces the ultrasound, which is then sent to your body. The sound waves are then reflected by the different parts of the body, the different layers which are having different densities. So you can simply write through by the different parts of the body, and finally received by the transducer, that reflected or the echoes are received by the transducer, and then with the help of the electronic devices, computers, sophisticated instruments, the final image is produced on sonogram. So this was about how the ultrasound imaging works. The similar technique is used by the bats to locate their prey. So as you can see, this is bat, and what's happening here is with the help of its mouth and nose, the bat is producing a high frequency sound waves which is called ultrasound. Now this ultrasound is being sent, and if there is, suppose there is prey, this is a butterfly, comes in its path, then obviously this is a property of a sound wave, or for any wave, that when it touches a surface it gets reflected back. some of the some of the waves get reflected back, some of the waves get refracted, and some of the waves get absorbed. This happens with the every wave. So as soon as it touches the an object, then it reflects back from that, and ultimately processed by the ear and the organs inside that bat, and the bat is able to do the imaging, just like the ultrasound imaging on the sonogram. You can see the images. Similarly, in its mind, the bat is able to process to see that image and is able to locate its prey. So these all working exactly the same can be said for the dolphins, and the ways they use the same, and for the sonar, the high technology that works on the same principle. So basically I have covered the theory in this video, and in the next class we'll be doing the seismic waves, P and S seismic waves. We'll be doing some questions on the sonar. There are some questions where you have to calculate the distance, time, that we'll be doing, and we'll start the light wave as well. So just keep on revising. You can access this free material on our website, which is www.akziacademy.com. And same, I'll be saying that if you want to enroll yourself for the GCSE batch classes, or for one-on-one class from year 1 to year 13, as exams are near, we are running the doubt classes as well. So only for the doubts you can enroll for the classes, and what all you need to do is just email us at exacademy@gmail.com. So that's it for today. Thank you. Have a great day. Keep revising.